Now, I am going to explain about big data analytics with Spark. So, nowadays, every organization generating huge amounts of data. Day by day, every organization, huge amounts of data will be generated. We live in the digital era. So, from small organization to large organization or individual also generating huge amounts of data. So in this data, we will finding some hidden information. That information useful for the organizations. So we'll start one by one. What is a big data? So actually, big data is refers to a collection of data sets so large and complex. Big data, nothing but a collection of data so large and complex, it is impossible to process them with the usual databases and tools. Because of its size and associated numbers, big data is hard to capture, store, search, process, analyze, and visualize. So, big data, nothing but a large amounts of data. Or nowadays, big data, nothing but a four V's: volume, variety, velocity, and veracity. Four V's. So big data, nothing but a four V's. Volume in the sense, huge amounts of data, size of data, nothing but a volume. So huge amounts of data with diverse types of data. So volume of data. Variety, nothing but a different types of data generated. So, like a very different types of data will be generated from other all organizations. So, in the sense, structured data, unstructured data, semi-structured data, like that. Velocity, nothing but a so speed data generated so fast. So within this fast, we will analyzing data also important to the organizations. Velocity, speed of the data. Veracity, data, nothing but a undoubt. So perfect, what was data we have collected? Perfect data is there. That is called veracity. Then perfect data is there. So unnecessary data not there, only perfect data. Data was perfect data called veracity. So these the four V's, nothing but a big data: volume, variety, velocity, and veracity. And 50 V also there called as a value. Value means we will finding information that is useful to the organization. It's called fifth V, value. But what about big data? Big data, they but a huge amounts of data. But what is big data analytics? Big data analytics is the process of examining large amounts of data. So we'll examine the data, we are finding some hidden information, or we are drought insights. These insights are useful for the decision makers. There exists a large amounts of heterogeneous digital data. Big data is about data volume and large sets measured in terms of terabytes or petabytes. This is called as a big data. Big data. So this is the big data, nothing but a huge amount of data, large sets of data with different types of data. We are finding hidden information in this data. So what is before that? What is a data analytics? So data analytics is the process of examining raw data to uncover insights, patterns, and trends that can help in decision making. So, data analytics is the process of examining raw data to uncover insights, patterns, and trends that can help in decision making. Nowadays, plays a crucial role in business, healthcare, finance, marketing, and various industries by enabling data driven strategy. So it mainly different organizations are using for enabling data-driven strategies. So but analytics guide decision making. So analytics mainly it guides the decision making by discovering patterns in data using statistics, programming, and operations results. Data analytics is transforming industries by providing actionable insights, improving efficiency, and helping organizations stay competitive. From understanding past trends to predicting future outcomes. Understanding past trends to predict future outcomes and making real time decisions. Analytics is a key driver of success in today's digital world. So this data analytics. And now types of data analytics. Different types of data analytics are there. That is called descriptive data analytics, diagnostic analytics, predictive analytics, and fourth one, prescriptive analytics. But descriptive analytics, nothing but what happened in the data. So this is the most basic form of analytics that summarizes historical data to identify trends and patterns. So simply we are finding summarized data to identify trends and patterns. For example, a hospital analyzes patient admission records to understand seasonal illness records. So this is called descriptive analytics. To summarize historical data to identify trends and patterns. And one more, the next one, diagnostic analytics. Why did it happen? Diagnostic analytics, why did it happen? So we are going deeper into data to find reasons behind past trends and events. We are finding reasons behind past trends and events in the organization. For example, e-commerce business analyzes customer drop-off rates to identify why users abandon their cards. So this is called churn prediction, churn analyzing, churn prediction, root cause analysis. And third one is called predictive analytics. What will happen? What will happen in the business? So uses statistical models and machine learning to forecast future trends. So for example, the predictive example, a bank manager predicts whether customers are at risk of defaulting on loans or not. Suppose a bank manager wants to issue a loan, the bank manager predicts a customer is the loan is issued to the person, it is a safe or risk. So this type of predictive analytics applies. Then fourth one, prescriptive analytics. What should be done? Prescriptive analytics, what should be done? It provides recommendations for the best courses of action based on data insights. So these only based on the decision making to apply this one, what action would be taken based on the present scenario like that. A ride-sharing company like Uber uses AI, artificial intelligence, to suggest the best routes for drivers based on traffic data. So this is called prescriptive analytics. So these are the 4 types of data analytics. And this analytics finding what are the technologies are there. So this what was the big data analytics, huge amounts of data collected. What are the technology? Because existing technology is not suitable for processing. Then what are technology required? One of the technology was came into existence, Hadoop. Hadoop is a software framework. It is a complete ecosystem designed for storing and processing large data sets across distributed clusters. So Hadoop is a software framework used for storing and processing huge amounts of data using distributed computing. And Hadoop components, mainly 2 components. One is the HDFS map reduce. HDFS, nothing but a Hadoop distributed file system. Hadoop distributed file system, it provides a storage. Data will be distributing into different missions across clusters of computers. MapReduce is a programming model for batch processing. HDFS is a storage component to MapReduce is a processing, because big data will be processed the computation. MapReduce, in between HDFS MapReduce, one more called yarn. Yarn nothing but a yet another resource negotiator. It manages clusters resources and scheduling done by the yarn. So these are the Hadoop components. But Hadoop offers a framework to handle both storage and processing. Storage and processing. But later, Apache Spark came into existence. So Apache Spark is also one of the big data processing engine. Apache Spark is a unified analytics engine for large scale data processing. Because Hadoop also came into it. Hadoop is a drawback for slow process. It can be used for a lot of disk IO transfers taking place. So Apache Spark is a open source, fast and distributed computing system designed for large scale data processing. So it is a open source, fast and distributed computing system designed for large scale data processing. It runs on clusters and provides high level APIs in Python, Scala, Java and R. It was developed to overcome the limitations of Hadoop's MapReduce, such as inefficient data processing and latency issues. So Spark is a multi-language engine for implementing data engineering, data science, and machine learning projects on single node missions or clusters, group of missions. So Spark is a multi-language engine for implementing data engineering, data science, and machine learning on a single node to group of nodes. Then what is the Spark architecture? Mainly Spark is a distributed computing framework. Distribute data will be distributed different clusters, all done parallelly. So in this architecture, driver program, cluster manager, worker nodes, executors, actually Spark is a master slave architecture. One of the node as a master, remaining as slaves. So master allocate the work to slaves. Slaves are done parallelly. What task is assigned by the master? So here driver program. The main entry point of Spark application is a Spark context. It manages the overall job execution and resource allocation by the driver program. It is nothing but a master. So driver program is the main entry point of a Spark application. It manages overall job execution and resource allocation. And driver program contact the cluster manager. So cluster manager is a entire cluster manager allocating resources across clusters for Spark jobs. It ensures Spark components are launched on cluster nodes. So cluster manager manages the overall resources or allocating resources to different Spark jobs. Then one more node you call worker. More than number of worker nodes are there. Worker node means slave. Worker nodes that are the missions that run application code and store data. Worker node run the application and store the data. These are missions in the cluster that execute Spark tasks and store intermediate data. So worker one master node, nothing but a driver node, driver program, number of worker nodes run the actual code and store the data. But worker node contains one more called executors. Executors are processes launched on worker nodes to run tasks. Actually, tasks run by the executors. Executors are the worker node. So executors are processes responsible for executing tasks and storing intermediate data. Executors run on worker nodes. Each worker node can run one or more executors. So this is the master slave architecture. Worker nothing but a slave, driver but a master. So master allocating the distribute the data task. Task is given number of stages. So stage tasks are assigned to different worker nodes. So each worker node contains number of executors. Executors are done by the parallelly. This is the Spark architecture. And Spark ecosystem. Spark is not single, it is a concerned group of systems. So the main difference between a Spark and a MapReduce is that Spark process and retains data in memory for subsequent steps. So this is the main, that's why how the Spark is fast means based on the in-memory computation. Spark using in-memory computation, but MapReduce process data on disk as there. Data is there in the RAM only in the Spark, but disk on the for MapReduce. That's why MapReduce slow. So this as a result, smaller workload Spark data processing speeds up to 100 times faster than MapReduce. So Spark is a more speed, 100 times speed than MapReduce. So because of why means Spark using in-memory computation, but MapReduce using disk. That's why so even though 10 times IO transfers in the 10 times, actually PySpark transfers 10 times faster than disk IO. That's why this ecosystem Spark, one of the ecosystem Spark SQL, it runs the SQL data with Spark SQL, one ecosystem, and Spark streaming data using Spark streaming. MLab is called machine learning data using, and GraphX, number of packages are there, is called actually data sources. Then create actually Spark concept creating a number of RDDs, data frames, and above number of packages are there, this one, then this one. And one more nowadays, PySpark is there. So PySpark, Spark plus Python equal to PySpark. Spark plus Python equal to PySpark. So in a today's data-driven world, handling massive volumes of data efficiently is crucial. So PySpark, the Python library for Apache Spark, offers a scalable and high performance solution for big data processing. So PySpark is a Python library that serves as an API for Apache Spark. It acts as a bridge between Python programming language and Apache Spark, which runs on JVM, Java Virtual Machine. PySpark is extensively used by Python users for performing data analytics on massive data sets and building applications using distributed clusters. So PySpark offers a comprehensive set of features, make a powerful tool for distributed processing. Its scalability, fault tolerance, in-memory processing capabilities support different data formats and compare with other Spark component. So that's the main features of the in-memory computation. PySpark done the computation in memory. And one more is lazy evaluation. Actually, lazy evaluation is the computation is deferred until when it is called. Actually, entire PySpark operations, two types of operations are there. One is called transformations and actions. Transformation is but the RDDs. Actually, PySpark supports RDD, resilient distributed data set or data frame. These are the main fundamental building blocks for working with data. A data frame or RDD will be created, and based on this, number of operations are applied. But operations are triggered when it is called. That's why lazy evaluation by the PySpark, one feature main lazy evaluation. The operations are not done immediately until it is called. That's why lazy evaluation and fault tolerance. Actually, one of is called fault tolerance. When the node failure occurs, then immediately one more node would do the same computation without stopping the work. Fault tolerance and immutability. Actually, RDD, one of the main component of the PySpark data frame called resilient distributed data. RDD is the main basic building blocks of the objects. It is used to operate data. It is immutability, do not modify. So these are the various features of PySpark. PySpark features. So PySpark it is a parallel and distributed computing engine used to perform big data analytics. In the era of big data, PySpark is extensively used by Python users for performing data analytics on massive datasets and building applications using distributed clusters. So, but why using PySpark? It is a scalable. Spark can handle petabytes of data across a distributed cluster. It is scalable for big data processing engine and mainly speed up. Spark process data in memory, making it much faster than Hadoop MapReduce. And ease of use, because PySpark, simple syntax and a lot of libraries are available to work with Spark. And unified processing. PySpark enables processing of various types of data, including batch data, streaming data, machine learning, all in one. That's why called a unified engine. And integrating with Hadoop, Spark can run on top of Hadoop clusters and Hadoop distributed file system using this one. So in the era of data-driven decision making, mastering PySpark is essential for extracting valuable insights and unlocking the potential for big data. This is the PySpark. Simply, then what is our means here? We are concluding this session. This framework is even faster than previous data processing engines like Hadoop. Nowadays, companies IBM, Amazon, Yahoo are using Apache Spark as their computational framework. The reason companies choose to use a framework like PySpark is because of how quickly it can process big data. So in the era of data-driven decision making, mastering PySpark is essential for extracting valuable insights and unlocking the potential of big data. So these are the conclusions. So I have given the overall view of the how to using PySpark with big data processing. Thank you for